All right, in section 2.3, we just a very brief video for you to estimate derivatives of a function. These are the functions that either we don't have a function definition, we don't know what f of x is, like this first example, or we would not be able to use our current rule for derivatives to estimate the derivatives. So we have to have a different way of doing it. We're going to rely on our slope formula, f of x minus f of a over x minus a, and for both of these examples here. So the first one, we just have this table, and here's our target value of 2 because it says h prime of 2. All right, and we want to estimate based on the things that were given. So some people might decide to use different intervals. Somebody could use -1 to 4 and use that as an estimate for 2. Somebody could use 0 to 3. Somebody could try 0 to 2. We have all of these different options. As it turns out, the one that you want to use, the one that is the best every single time, is the smallest interval surrounding your target value. So in our case, we're going to use the interval from 1 to 6, or to 3, sorry, 1 to 3. So we're going to use those values in our slope formula just like we normally would. Okay, check out this really cool notation here. Remember, approximately equals 2, so you have to use those squiggly ones. All right, and we're going to use this pretending like we're doing f of b minus f of a, so we would want a -2 minus 6 over 3 minus 1. Now that fraction is equal to, so now we use an equal sign to continue, and we get -8 up top and we get 2 on the bottom, so that equals -4. All right, so our final answer is this -4 is the best way, or the best estimate of h prime of 2. So h prime of 2 approximately -4. Maybe we want to write our answer that way. Okay, be very careful where you're doing approximately equal to and equal to, because it does matter. Okay, here, calculate an approximate value of f prime of 2 where f of x is equal to tangent x. I don't have values for tangent. I could calculate them. We have calculators. And I couldn't really do like tangent x plus h because I don't know what that is. So we're stuck with estimating again. And our target value is 2. So we want to use a very small window around or including 2. So maybe to approximate f prime of 2 here, we do f of like 2.0001 and f of 2. Those two things very, very close. So we'd have our points very, very, very close. So we could do it that way. And then I'm just going to end up, I forgot those were approximately. Here we go. I need the tangent of 2.0001 minus the tangent of 2 over 2.0001 minus 2. And calculating that, make sure you are still in radian mode for calculus. The tangent of 2.0001 minus tangent of 2 altogether is 0.000577. I don't want to round too much there. And 2.0001 minus 2, of course, is 0.0001. And when I divide those two things, I get an approximate value of 5.773 because I just kept all of the calculations on my calculator. And in calculus, our rule is to round to 3 decimal places. I believe Mr. Picard had you do that last year in pre-calc 2, but for sure, calculus, anything rounded, final answer needs to be rounded to 3, or you could truncate to 3. Down here you see something that's online derivative graphing fun. Totally fun things, but I want to talk to you about those when you're in class instead. So I'm not going to use video time for that. Just approximating our derivatives when we can't do that the other way is this video. So look forward to online